Hello, everyone. Welcome to a new week. It is Monday. Welcome to a new day when we attempt to solve Advent of Code puzzles. And we've been doing pretty well so far, I think. We've looked at unit testing. We looked at GitHub Copilot. We wrote our own read function. And yeah, we are now at day 3. So without further ado, I will just get on with it and take a look at today's or day 3's puzzle. So if you remember, we are on our journey into the starfruit forest, I want to say, or jungle probably, with the elves to collect some starfruit because they need that for energy or something. And every day we will encounter some new peril that requires us to do some mathsy stuff, I guess. So today we're reorganizing rucksacks, apparently. One elf has the important job of loading all of the rucksacks with supplies for the jungle journey. Why is there a... Oh, okay. So it's pointing to the Wikipedia article for rucksack. Cool. Unfortunately, that elf didn't quite follow the packing instructions, so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly one item type per rucksack. The elves have made a list of all of the items currently in each rucksack. That's a puzzle input, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is, lowercase a and uppercase a refer to different types of items. The list of items for each rucksack is given as characters all on a single line. A given rucksack always has the same number of items in each of its 2 compartments, so the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. For example, suppose you have the following list of contents from 6 rucksacks. So this is our test input. I'm just going to already save it because we already know that we'll need to use this shortly. It's test input. All right. First rucksack contains the items, these ones, which means its first compartment contains the items, these ones, and then the second compartment contains these items. So we just split down right in the center, and then this is the first compartment, and then this is the second compartment, this one. The only item type that appears in both compartments is lowercase p. The second rucksack's compartment contains this and this, the only type of blah, and so on and so on. To help prioritize item arrangements, every item type can be converted to a priority. Lowercase item types A through Z have priorities 1 through 26. Upper case item types A through Z have priorities 27 through 52. In the above example, the priority of the item types that appears in both compartments of each rucksack is 16, 38, 42, 22, 20, and 19. The sum of these is 157. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of these item types? Phew. So this is day 3 now, and the puzzles are getting a bit more elaborate. Most of the time what it means is just we have to do multiple different things until we get to the final result. So in this case, we first have to split up our string in the right way, and then find kind of the thing that is double, that appears in both the second half and the first half. Then we have to take this information and then look it up in some kind of dictionary probably, and then we have to sum that up. So we have to do like 2 or 3 different things here. And this is where I am super happy that we've decided to go with tests, because tests will make these things very structured. I do personally like to have a lot of structure when I'm writing code. So I can write a test for each individual thing that I need to do. separate from each other. Like I can isolate these tests so they just only focus on the one thing that I need to test. And then we can just make sure that every single thing works. And if there's something, if we later refactor or change things for part 2, you can see which exact part of our solution is broken, instead of just knowing that something's broken in the entire thing. The way that we did it before, we just tested the entire part, we just tested part 1. And if something broken there, then, we just have to like focus, like just go through every single logical unit that we built. So I'm going to explain what I mean. So let's first set up our test function. And I'm just going to copy paste this part because I just can't be bothered to remember. And we need to import day 3, which is a file that I am going to create right now. And then we are going to, so what we're going to do first, I want to test just the part that, I'm not going to test just the splitting the string. I think that is something that we don't have to test separately. I trust myself that I'm capable of writing code that works. But maybe just a function that finds out which item type is doubled. So I'm going to create a function here that's called def find duplicate. And so in Python, we do snake case, which is the which is not camel. So camel case is camel case, and snake case is when you use a underscore. So in Python, the convention is to use snake case. And so this is already Copilot suggesting things to me. So I'm going to get like the entire string here. So the entire, let's say the entire rucksack. So I want to get the entire rucksack here, and then I want to return duplicate type, right? So I'm just going to, just so it doesn't complain, I'm just going to return an empty string here. And in my test, so I know that for the first one, this one, the only item type that appears in both compartments is lowercase p. So I want to assert that if I pass day3 dot find duplicate type with this whole string, I want to assert that I want to get p out of this, right? Because if we pass in the string, the only item type that appears in both compartments is lowercase p. And you know what? We can like run the same test with multiple test cases later, but we're gonna start with this one first. So this is our test now. So we are just testing just this one functionality. And I am going to just make sure that our test fails. If you remember, when we're doing test-driven development, we should always make if we write a new test, it should always fail first. So we can make sure that when we implement and then it turns into green, it turns into pass, that it's actually the logic that we built that made it pass, and not the fact that we just set up the test in a weird way. So it has always been green because we were just weirdly testing true equals true or whatever. So this is our test, and it fails because we are passing an empty string back, and that is not lowercase p. So let's get to it. So the first thing we need to do here is to split our string right at the middle. Multiple ways we can do that, but as we're using Python, I want to really use like list slicing again. So the way that we can do this is just looking for that one part. We know the index, like I'm going to call it middle index or whatever. So that this is the index of the, look at GitHub Copilot. I don't even have to do anything. So GitHub Copilot already tells me, hey, just, divide by 2. And then that's the length of my rucksack, of all the items in my rucksack. So the size of my rucksack, if you just like divide it by 2, so this is the regular divide. If I have like 2 slashes, I'm dividing and casting to int, I think, immediately. Which we need to do because this one always returns a float. So if you just use this, it always returns a float, even if it's like, if we know it's an even number. But this one returns an integer. So we know the middle index is this already. And then we can get the first half by basically saying this. So we start with 0 and we're slicing until middle index. And we can, and then the second half is this. And we can leave out the 0, and we can leave out the number that we would put here, which is we would put len entire rucksack at the end, because this is the last index. And we can just leave that out, because if we omit, then Python will just use the default, and the default is the beginning or the end, right? So instead of like using this, if we just leave the 0, then Python will understand that we want to start at the beginning. So this is the first half, and this is the second half. So just for full, completeness, we're just gonna call it first compartment, and then this one is the second compartment. Okay, now we have to find the duplicate. So how would you want to find the duplicate? For one thing, if we just print first compartment, second compartment, we have to leave this. If we just print these 2 strings right now, or like, yeah. So if we do this, then we can see that already there are some duplicates, like this uppercase F. It will always, it is there multiple times, right? It's 4 times in this, which is fine. It doesn't matter. We can have multiple of the same item type in each compartment. What we're looking for is the duplicate that is in both these. And PyMaster had a great comment, which is that just using this, just basically slicing everything, because I said like this is if we omit the first one, it will just be the beginning, and if we omit the last one, it will be the end. So this basically means the entire list. And yeah, you can just use it to copy all the elements from one list to another, and then it's like, it's not the same object anymore, but it has the same elements. All right, thanks for that very useful tip. Okay, so one way, well, this is how I would go about it. First of all, I would make sure that I only have unique letters for each of these strings, because I don't need like the entire string. I just need to know which unique letters exist. And then I can compare both these unique letter lists with each other and just find the one that is in both. So if you want to have a list of unique items, one way to do it, you can just obviously do a list and then just like check if this element already existed in the list while you're iterating over it. The other thing we can do is use sets. Sets are pretty much, well, they're not lists. I think they might be, they're definitely iterable. So they're probably implementing some kind of iterable interface. But they are objects. And you can create a set from a list, I think just by passing in the list. So let's just see if this works. And by doing this, automatically, we should probably get rid of all the duplicates. So let me just so we can see, just gonna print the list first and then see what happens if I want to make a set out of it. So this is our list originally. And now this is the set that we have. And as you can see, like every character is now separate. It's a separate entry in the set, and all the duplicates have gone. So we only have like lowercase w, we only have it once. Uppercase W, we only have it once. So we're going to do this with the second compartment as well. So first, I'm just going to call it first set now. Oh, you're already, come on, Copilot, you're already giving away the next step. So now to find the overlap between two sets, there's this function called intersection. And we can call that on, as we have it here, we can call the function intersection on one set and pass in the second set. And that will give us the overlap. So we could probably just return, let's just return the result and see what we get. Okay, so return the result, and then now we're getting, okay, so P is the correct answer, but we're returning it as a set because the intersection function will return a set. What we need is the actual letter, and you might have seen that Copilot already gave us that result as well, which is we can just use pop, just as we would use a list, and that will just return the last entry to us. Or we could call it with the index. That would also work, but let's just do pop. Well, that was it. Okay, I'm just going to clean up a little bit because, let's clean up later. So now we have one test case, but then in our example, in the test description, in the puzzle description, we have 1, 2, 3, 4, 5, 6 rucksacks. And we want to make sure that this works with all the rucksacks, right? So let's just build a couple of more test cases for this. So we just run the same tests with multiple test sets, basically. So this is our second rucksack, right? And we're just gonna change the test name. We're gonna call it test duplication and oops. So I'm gonna create. Oh, no, I'm not gonna create a list. I'm just gonna read it because we already have this all of this together. So I want to load all these strings from a file and then populate them with our test. So I will import read, my self-made read function, read from file, and then I have to pass in the file name, which is day3 test input. And then I should get I could get one list with individual strings, right? Okay, so now I want to, for each rucksack in this list of rucksacks, I want to call this function with rucksack, right? But oh no, now I'm in probably the second call or something. Yeah, I'm still asserting P, which is obviously not actually true. So what I actually need to do is I need to put in a bit more effort to set up my test case. So these are my rucksacks. That's fine. But then I also need to make sure I know what is expected for each line of these rucksacks. So I could either just copy and paste this, like just literally just make this like a list. I think I'm gonna do that. I could obviously also iterate from the here and then just set things, but then it's gonna get much more complicated. So I'm just going to create a dictionary. I have to do it like this now. So for this one, I'm expecting P. And then for this one, I'm expecting L. I mean, GitHub Copilot is smart, but I don't think it will be able to figure out this pattern just from looking at it. I mean, it might. I would not be surprised. So here we are expecting P. And this was lowercase v, t, and s. Okay. V, t. Oh, look. Did you see that? Oh, I was wrong. I'm so sorry, Copilot. You were always going to be right about this. Okay, so this is now my test data. And then do I want to iterate? You know what? I don't actually want to iterate over. I guess we can do it. I'm not actually sure how to now access each entry. Do I call key and value or something? I don't actually know. Yeah, because it's only printing this entire string, but I don't have access to the value. So it's printing the key, and then to access the value, I have to just access. Yeah, okay. Fine, I guess I can do that. Okay, let's do that. Thanks, PyMaster. Rucksack is the key. And test data rucksack is the value. You know what the key actually is? The key is love. I've been listening to a lot of Christmas music earlier, so. Okay, so this is our key. So we pass in rucksack here, and then we expect test data rucksack. So, and then, I mean, this is actually, I don't know if this is super ideal, but because now I changed the test, and it would be nice if it would now fail first, and then I have to implement, and then it's okay. But now because I've implemented this function so well that it will just like pass, because I already implemented, theoretically what I should have done. This is actually the right way to do it. Before I put in all the test data, and I just had this one, right? I'm just testing this first entry. What I should have done is here just return lowercase p, because I'm only trying to make the test green, and I'm only putting the least amount of effort in to do that. And then when I test like the second one or all the rest, then I actually have to start implementing the function, right? Because there's no other way to get to make both of these be green unless I actually implement the function. And that would be the right way to like do proper test-driven development. But I guess in this case, it's all right. I mean, like, the functions are not super complicated right now, so it's probably all right. But yeah, generally the rule is don't implement too much, just implement enough to make the test green. So, and we haven't done the entire part one yet, right? We only built the function to actually find the duplicate type. So what do we need to do with that now? So the next thing is, now we have to find out what the priority is for each of these letters. And we have this information here. Lowercase items A through Z, and then, so this is basically a list of numbers from A to lowercase a to uppercase Z. And I'm just going to do this with a loop, right? I mean, I guess we could maybe look up the number, like some kind of numerical representation for the character in some kind of like Python implementation, blah, blah, blah. But I am way too lazy to do that. So what I would rather do is just, build a list for that. But before we do that, let's first write the test. So this test is get priority. Test get priority from a. So we want to assert equal that if we pass in lower p, we want to get 16. This is our test. Oh, wait. Not quite. Get priority. So this is the function that I'm going to build. And we pass in the letter, and we expect 16 to come out of there. So when I run this test, it should fail because I haven't implemented that function yet. Yeah, so day3 has no attribute get priority. So we need to implement this function. Get priority, and we expect a string. And then so now we can do, let's just return, what was it? 16. Right, and then now our test passes. So yeah, we implemented this. Awesome. We're so good. So now we're going to do the same thing again that I did here, that I did before, which is we're now building the data structure for our multiple test cases to make sure that this is actually an implemented function and not just something weird. So, like there's things like randomization, where you like a function that always returns a random value. You could implement one that always returns 4. I think there was an XKCD about that. And there's no way that you can like mathematically prove that it's not randomly giving you numbers and it just happens to always be 4. So yeah, it's very tough to test randomness. Anyhow, so yes, our test data. Thank you, Copilot. We're gonna do if I put this like this here, right? So I'm giving this information, and then I'm starting to set this pattern. Do you see that? Yes. Okay, but now just give me the entire thing, right? Why am I still hitting? Am I still hitting tab and enter manually? Oh, we're done. Okay. All right. So now I will write my loop where for each letter in test data, get priority letter test data. Yes, that's it. That is it. And I feel like I'm the I'm the co-pilot here, honestly. Okay, so now, yeah, 16 is not equal to 38. Oh no, why? Okay, we have to actually implement something here once again. And as I said before, I think I would just want to have a, list. I just want to do like freaking. Actually, I don't even need a list. I mean, if I had a list of like just all the letters, then I could probably, by virtue of just like knowing what the index is, calculate this. So I know that in Python, there is something like input from, I think it's from string. Like letters need to Google this. Python. Just the alphabet in Python. ASCII lowercase, that's the name. Okay. There's ASCII. And then there's did I import it the wrong way? It's just import. Is it import from string and then the name? I don't think so. Getting way too ahead of everyone, PyMath. So let's just like do one step after the next. I guess we could just import string and then call whatever we need from there. So there's it's lowercase, uppercase, and letters. So we could just do letters and then we get all the letters. So let's just see. Is this just a list? It looks like it's a string. Yeah, literal string. Okay, so if I want to find out the index of A, what will it tell me? Will it tell me like 1? Oh, okay. Wait, what am I doing? This is a function call. It will tell me 0. Oh, this is actually perfect then. So all I need is to call index and then add 1, and that's my priority. So, okay. Right. That's it. Well, that was almost too easy. All right. So, okay. So I have tested both these functions now. These are the two main things that I needed to do for this puzzle, I would say. So now I basically have to figure out for each rucksack which is duplicate and then what the priority is, and then sum this all together. And the sum of these is 1457. So now I feel like I'm ready to test everything together. So I'm going to now build my dev test part 1 test. And we will, what will we do? Will we read here and then pass it in? No, we probably just want to put in the file path and then have it load that. So I'm going to pass in day3 as input txt, and we expect 157. Right, so now I will implement this function. Yeah, I'm just like, I feel sad now because I don't even get to do anything anymore. It's already told me, okay, just like open this and then go line by line. It's not even using my cool read file function anymore because it doesn't need that. And then the total is just, if we're like first finding the duplicate type and then passing that into the get priority function, and then we just like add that up. Like, I really want to know whether Copilot knows this just from like inferring from the functions that I've built so far, or because a bunch of people have already implemented more or less this as part of Advent of Code. Like, I just want to know whether, you know, is it still being trained right now? Is like, are these things part of the model? Like, is it still ongoing? Is the training still happening in real time? Because that would be amazing. It's still amazing in any case. Yeah, I mean, like, I wouldn't have expected it to fail, honestly. All right, let's pass in the real deal. So we're gonna run part 1 with day3 input txt, and we're gonna print that. So this thing Copilot never reminds me of to also print my solution. Oh, I don't have a input txt. Man, I wish you know what, the next thing is just like, I'm just going to build a crawler that gives me just like the input and everything, and then I'm not going to forget that either. And then I'm one of those evil people who just have everything done by AI and are not putting any effort into solving anything by themselves. Oh, forgot the 3. Right. 7727. Yeah. Again, sounds like a reasonable number. Let's see if they agree. That's the right answer. All right. I am 1 gold star closer to collecting enough star fruit. Let's check part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in the rucksack, and at most 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above sample, this one's so this is the first 3, then the second 3. We have 2 groups there. First group, the only item type that appears in all 3 rucksacks is lowercase r. The second group, their badge item type must be Z. Priorities for these items must still be found to organize the sticker attachment efforts. They are 18 for the first group and 52 for the second group. The sum of these is 70. So find the item type that corresponds to the badges of each 3 elf group. What is the sum of the priorities of those item types? So if I understand correctly, now we are not splitting the string in the middle anymore, but we're just comparing like full strings here. Like we're just comparing 3 strings instead of 2. So let's maybe change our function a little bit so we can reuse these things that we've tested before, because that sounds great. So one thing is that maybe instead of passing in 1 string, because right now we're passing in 1 string and the find duplicate type function will just split it in the middle, which we don't want anymore. But instead, why don't we make it more generic and pass in a list of strings? So basically, we split the string before we pass it in, right? I feel like that is maybe nicer. But then we might have to like, we have to, yeah, maybe we have to like change this so the key is the value and the value is the key, because I don't know if the key can be a list, but I guess we can find out. So we're gonna do this then instead. Just gonna split this in the middle. Then I'm just gonna cheat a little bit and look this one up. So this is the here, and then I wish it would just tell me. Yeah, it does tell me now, but not in the later ones. Which one, like, where the halves begin and end. Right? Yeah. So what do I do? Do I just like hit enter and like this is not the right size? No, it's not right. Just like eyeballing it right now. Yeah, this looks right. Okay. And then what PyMaster is saying? I think the average answer for part 1 should be 7,950 equals 300 lines, and assuming it's the same index position between. I don't even know what that means. 300 lines in input file, assuming it's the same for everyone, times 26.5 average index position between. I see what you're saying. Yeah, so I guess. I would also be interested. So basically, what PyMaster is getting at is that the result for part 1 should be kind of in the general neighborhood of 7,950, because that's the mathematical, I guess, median for the answer. I would assume that everyone gets the same lines of input, but I could imagine that there's some really, like, there's someone has some edge cases. They're clearly generated, right? There's no elf coming up with the test cases. Any case, so I'm still like manually figuring out where I could write a code. I could write some code for this as well, but I just don't want to. I feel like it would take me longer to do that than just like eyeballing this right now. And it's not about the solution. It's not about finding the solution quickly, because if it was about that, then I would have solved this. I would get up at 6 a.m. and then just solve it. But I don't want to. So we're passing in rucksack here. And now rucksack is a list. So unhashable type list. Yeah, okay. So let's flip this then. Let's do... Maybe Copilot can again do this for me, so I don't have to do it. Well, almost. Come on, Copilot. I've shown you the pattern. You can do it. You can do it. No, that's not it. No. Okay. Well, okay. Maybe the next one. Maybe you'll get the next one. I'm giving up. But now we finally found its weakness. That is right. That is the minimum of string that has to be in the rucksack for that condition to be true. For that to be an actual duplicate. Okay, so now we have to put test data rucksack in there, and then expect rucksack to come out. Now rucksack is not the best key anymore for this. It should be like that actually. It's still gonna fail because we haven't implemented that. So now there's some logic in there that doesn't work anymore, which is good. So now instead of this, we don't need first compartment, second compartment, because we already have all the compartments. in a list here. And I could do, obviously, I could do all compartments. Compartments 0, and then all compartments 1. Pop that out, and then we should be, except that this is a string and not a, oh wait, they're not sets anymore. I removed that part. So I have to make these be sets again. And then I get another error, which is good. Errors are always good because it tells you what you're doing wrong. So pop from an empty set. All right. I might have messed up some. Let's do one by one. And compartments 0. See, this is what I mean by it's really good that I have these tests, because if I was just like running the entire thing, I would either, okay, I might see the same error, but then if I don't have any syntax errors, but I still have some logic errors, it would be really tough to find out where exactly the error has occurred. So this is actually makes my life much easier. So now I'm printing W. Oh, wait. Oh, I know. I think I know why. Because I'm passing in for the this is a separate test that's failing. This is this test that's failing. Let's just ignore this test for now. Let's just focus on making our actual unit test work. Okay, that's just a typo. So all compartments is just one string instead of a list of 2 strings, because we are we passing in run? What are we passing in actually? We are passing in this string. What is this string? Where is it coming from? Oh wait, that's not the string. That's our result here. Okay. So now it works. Okay, now it makes sense. Now the test is good. Yeah, that makes sense, because we haven't actually fixed everything yet. Okay, so we can do this, right? We can just like pass in the first element, pass in the second element. But now, okay, let's make sure that all the tests that we have are running again. We should always bring our code and our tests and everything to a state where everything's green. So what's the problem here? Test input, and then here, instead of just putting the entire line in there, we need to now split the line. In line, get index thing of 9. Yeah, got that. And then we want one part that is the first part, right? And then we want, oh, already got that. This is the first part. Yeah, and then we have the rest of this. And these are 2 elements in our in one list. So now our test should pass. Fantastic. Okay. Split line. And yes, cool. So now everything works again, and we've just changed this function to, instead of taking a string and then splitting up in the middle, it will just take a list of strings and just find the duplicate letter in those. And this works with 2 strings fine. But now when we want to test these situations where now we have 3 strings, this is probably not going to work anymore. So let's see. So here, we expect lowercase r. So we add a new test case where and then we also add this test case, and we expect an uppercase Z for that one. Okay, let's see what the test says. Okay, so now we have this issue that we're expecting T, but it's we're expecting Z, but it's T. It's interesting because the R part apparently worked because it's the okay, so the reason why is because we expect this to be 2 strings, and then we don't look at the 3rd string. So what we can do is we could obviously do like a call this, and then call that, and then call that, and then call that, and loop through kind of what we're given. Another thing that we can do is, instead of calling intersection on a set, we can also call the intersection on the set object as a whole, and we can then pass in all compartments, but not like so. So if we wanted to do this, then it wouldn't work because it doesn't, it says that it doesn't apply to a list object. So we need to spread the list out. So instead of passing in the list, we need to pass in every single item on the list individually. And the way that we can do this is with this operator. And you probably saw it in the autocomplete already. So yeah, I guess. So it does set compartments for all, but we don't want to, I don't actually know if we need that. We might actually need to, but let's see. Let's just put in all compartments. And this one's too much. Let's see. Doesn't apply to a string object. Okay, so we do have to do sets. So let's just like take this thing that now it's a list. So okay, so now for all the compartments in this list, we create a set for it. We put all these sets in a list, and then we spread this list out with this asterisk operator. And now we're back where we were before, which is that this is correct, but we're returning a set. So now we're going to call pop once more to retrieve the last item in the set. And now it has a green. So we just implemented that we can now basically pass in any kind of list of strings to find the duplicate letter in there. Okay, so this was one part. And then the priorities once you organize the sticker attachment effort, here they are. Okay, so the rest is the same. It's just the way that this is called is different. So let's write the test for part 2. Well, it's not exactly the same, right? We don't do the split in the middle and check the 2 compartments, but we instead check 3 at a time. So there is a bit of difference in logic, but then the summarizing of the priorities is the same. So yeah, this is all correct, except that the value we're expecting is 70. Top and 70 in here. And then we will implement this function. So I'm gonna do this. Why are you not suggesting things to me now? Okay, so we're not doing this anymore. We are going to find duplicate type for so this is not as ideal anymore, I guess. Because now we're going line by line and it's not super ideal. Yeah, maybe I'm just gonna read it with my little read helper function thing here. Read file file name. It's my input. And then what I probably want to do, I'm just going to make sure that I'm still reading it the right way. Okay, I should call it. Okay. Yeah, this is line by line. Okay. So, no, I'm so confused today. I'm not there yet. I'm still implementing it. Okay. So yeah, okay, these are my strings now. So what I probably want to do is I want to, for, like in range length of the input, I want to get the priority for the duplicates of input line I, right? And then, actually, no, I think this is the right one. When I use 2 colons, I think I am defining the length, but you know what? I'm not quite sure. So let me just Google this real quick. Python list slice. List slicing. Initial and index jump. Okay. So what does index jump mean? Index jump. So then the above expression returns the portion of the list from index to end at a step size of index. Okay. So I don't actually want that, but what I want is just like index plus 3 or something, I guess. That should give me like a list of 3, right? Let's see if this is, if I'm making wrong assumptions right now. Unbound method. Yeah, okay, wait. We'll deal with that later. So this is giving me looks right though. This is giving me, a list of 3. Yeah. So this is what we want. We want to slice get 3 elements in here. This is what I want. Oops. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Okay, cool. So this is the right one. And then when I've done that, I want to set I plus 3 because I don't want to jump to the next one, right? Because we already dealt with that. I want to jump to this one now. So I'm going to set the index, the counter to 3 after that. I'm wondering if 3 is the right one or if it has to be 2, but I guess we'll find that out also once I run the test. And then if it fails, it fails. So maybe it's 2. Not quite. I'm wondering if this, because it's probably it's probably +1 actually, because this loop is going to add +1 to I anyway. So I have to stop just randomly guessing, I think. Okay. I will just have this print stuff out, and then we will see. Okay, so these are my first 3, and these are my second. No, it's not doing what I wanted to do. Because it's just always moving by 1 step. So let's see. Maybe there's something we can do with the range function. Maybe we can just tell range to not step by 1, but step by multiple. Yeah, see, there's a difference between H and numbers in this sequence. So start, stop, step. What if we don't want stop? Range stop takes 1 argument. Start, stop takes. Oh, we have to give start, stop, step. So I guess we'll do 0 length input and then I'm gonna say 3. Let's see, PyMaster also knows that range has a step parameter. That looks right. Hooray! So would range length input? Yeah, that's what I was wondering, but I almost feel like if we only pass in 2, then this would be the start and 3 would be the stop, because that's what the signature was saying. You can pass in range stop, range start stop, or range start stop step, but you can't pass in range stop step. Maybe if you pass it as named parameters. So this is failing now, but if we pass it as like stop and then step, maybe that will work. And range takes no keyword arguments. No, we have to go with 0. My suggestion includes that. Yeah, I understand, but I think this takes no keyword arguments, so we just can't. Yeah, we can't do it, unfortunately. But this is like close enough. This is pretty good already. Okay, so let's find out what the solution is to our actual puzzle. Okay, 3. 2609. Is this the right result? It is. That's the right answer. You are 1 gold star closer to collecting enough star fruit. You've completed day 3. You can share this victory or return to your advent calendar. I am sharing this victory with all of you 1 viewers. But this was really exciting because I really liked that we were building separate unit tests. Because this is before we were writing more of like integration tests, maybe like not even really, we weren't integrating anything. We're just writing one test for everything. But now we've actually separated our code, our logic, into individual units and then testing each unit separately. And you can already see that it made a huge difference for a lot of things. It made it much easier to change things, to refactor stuff. And also it makes it easier for you to know when to start and stop a lot, like what is a logical unit, which things belong together to one logical unit. You define that in your test. In your test, you basically define, okay, I want to build a thing that when I pass this string in here, I want this number out. And that's your logical unit. And you just write this one unit for now. And I love writing unit tests and writing test-driven code because it just helps me with the structure and helps me to know when to start and stop things instead of just constantly like spaghettiing down the hellhole that is coding. So once again, we managed in about an hour, which again, I'm not doing that on purpose, right? It just happens. Maybe I just keep talking, then my natural clock is just like, stop talking. We have to get shit done. So I will add the changes for today, except I'm gonna package stuff. Okay. What did I change in day 2 pi? Nothing of value. We could actually check if we reset day 2, so it's not staged anymore, and then we use the I didn't commit that last time. Okay, let's do that now. So we're gonna reset everything. Now I'm going to stage this. Optimize day 2 solution. Then I'm gonna stage everything else. Day 3. Okay. Spaghetti and speed both start with S. Coincidence? So does solution. And I'm sure there's a language that starts with S too that I just can't think of now that we could use, but I just don't can't think of anything. Python. Let's scroll down here. Swift. We could write our thing in, or like shell. Or SCSS. Cool. Alrighty. I think that's a good effort for today. We're getting really into the area where I'm probably gonna take more time to solve everything. I mean, I'm still pre-solving. So today I solved day 5 on my private account. So we are still good. Right now, around day 15, I'm usually getting into a bit of trouble. So we'll see how long we can make it. But up until now, it's been pretty nice. And thank you for watching. Thanks, PyMaster. You're my biggest fan. My only constant in this crazy world. Yeah, thanks for checking in. I hope you have a great rest of the day. And I'm planning to stream tomorrow again to do day 4 together. So I hope to see you there. And yeah, have a great day.